Welcome to part 2 of our pre-calculus trig lecture on the law of cosines. So here's the law of cosines, which we developed in part 1 of our lecture. Also in part 1, we did the basic side angle side problem and side 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 problems, which are the two that we use the law of cosines for when we're talking about solving oblique triangles. So now we're going to talk about a few application type problems in this video. So the way that I'm going to approach our application problems, I'm going to introduce several basic oblique problem scenarios, and they'll be applicable to whatever story might go along with it, but the backbone of the problem will be the triangle structure and the given information that you start with. Right, so in this problem here, it says find the length of B, so that's this side, and the perpendicular distance between the parallel lines, so these would be the parallel lines, and we're given C is 93, A is 67, and angle B is 27.4 degrees. All right, and we're trying to find side B over here, and also the perpendicular distance. So the perpendicular distance we'll call H. All right, so this kind of problem you see sometimes as the distance across a highway, the distance across a river, a stream, a moat, whatever, that type of a problem. All right, so let's go ahead and see what we're given. So we have a side, an angle, and a side. So that would be SAS. So this is an SAS problem. So we use the law of cosines for an SAS problem. And we start by finding the side opposite the given angle. All right, so we want to find side B. So we're going to use the B law. So I write down my B law. And I substitute everything in that I know. So I know A, C, and capital B, my angle. So the only thing I don't know is my side B. So all of my known quantities are going to be on the right-hand side. So this is the easiest way these come around to solve because you don't have to subtract and divide. All right, everything's on the one side. So I substituted everything into my equation, where my only unknown is lowercase b. So I'm going to type all of this into my calculator. I'm going to check it a couple times to make sure I'm sure of having done that correctly. And I get this number here, which I'll then take the square root of to give me b. So this would be in kilometers. So when I took the square root, I get 45.5 and some other digits, and I'm going to keep them all. All right, so I've got that. Now that answers the first part of the question. Find the length of B. Now we want to find the length of H. So here's H. All right, and so that's going to be a side of either, we can consider it a side of this right triangle or of this right triangle here. All right, and then in order to utilize right triangle trig to find H, I would need to know one of these angles, either this angle or this angle here. All right, so let's just arbitrarily say that I'm going to find angle C. All right, and so that means I want to use this triangle here to find H. All right, so let's find angle C next. So I need the C law. So I wrote down my C law. Now I'm going to know everything there except for angle C. So I'm going to substitute A, B, and C, lowercase A, B, and C into the equation. So I did that. Now in order to solve this, I'm going to take 93 squared, subtract this, which will give me a number on the left-hand side, Then I'll multiply -2 times these two numbers here, and that'll be my coefficient of the cosine of C. So I did that. Now I need to solve for the cosine of C, which means I will divide. So I'll be able to cancel out here, and I'll be left with the cosine of C. And I get this negative number here, which I'm keeping all my digits. Then I would take the inverse cosine of both sides, which will give me my angle C. So I'll end up with my angle C being the inverse cosine of that number, and I get 109.9875 degrees. All right, so now I have angle C over here. So from there, what I'm looking for is my H distance right here. So I needed my C here, my angle, to find my H distance. All right, so what I'm going to do next is over here, I'm going to say the opposite. So this is H is opposite side C. So that means the sine of the angle C is equal to H, and the hypotenuse is my 67 side. So this is my opposite, this is my hypotenuse. All right, so that gives me an H there. So if I substitute sine of angle C would be 109.9875 is equal to H divided by 67. All right, so that means H times 1 is equal to 67 sine of that angle, like that, and I get 62.964. All right, so we were looking for that. That's one of our answers, and then the side B is the other one of our answers. So this would be kilometers here, so let's put that in there so we don't forget our units. We always have to be careful with that. So H is that number in kilometers. All right, so we've answered our question, and this was a Law of Cosines problem because it started out as an SAS. So this next example says ABCD is a parallelogram, ABCD. So this is a parallelogram. It says one angle is 50 degrees, and the side lengths are 8 and 13. So we were just told the number of units, but not actually what the units are. Find the lengths of both diagonals. All right, so first of all, what is a parallelogram? So back to geometry, a parallelogram has opposite sides here. They would be congruent, and they'd also be parallel to one another. All right, and then the other two this way, these two are going to be congruent and also parallel to one another that way. All right, so we learned that in geometry. One of the angles is 50 degrees. All right, so with a parallelogram, you're going to have a pair of congruent acute angles. These two here are going to be congruent. So those must be your 50-degree angles here. And then you're also going to have a pair of congruent angles which are obtuse. All right. So in order to figure out what that angle measurement, those two are, we need to remember that the sum of the angles of a quadrilateral is, now instead of remembering a formula, I always think about it this way. Let's say you just have any arbitrary funny looking quadrilateral. Well, you can think about it, it breaks into two triangles. So the sum of the angles of a triangle is 180. So we have two triangles. So that means I've got all of the angles must add up to 2 times 180. So that's 360 degrees. So angle A plus angle B plus angle C plus angle D equal 360 degrees. All right, so we know that two of them are 50. All right, and we know that C and D are the same size, so we can just call this 2 times either one of them. All right, so this is 100. So that means 2 times the obtuse angle is 360 minus 100, which is 260. So the obtuse angle must be 260 divided by 2, which is 130 degrees. So these are 130. All right, so all of those added together would give you 360 degrees, which is the sum of the angles of any quadrilateral. All right, then we have the side lengths are 8 and 13, so that must mean the shorter ones are 8 and the longer ones are 13. All right, then the last question, the question itself says find the lengths of both of the diagonals. So let's do them one at a time. So if I draw in the shorter diagonal, there it is right there. All right, so that breaks up my parallelogram into 2 triangles. So if I just look at one of them, let's just say this one, they're both the same. I can use that triangle, that oblique triangle, to figure out the length of that diagonal. So I'm looking for this length here. Let me just call that x. I'm looking for that there. All right, so if I examine this triangle here, I've got an angle across from it, and I've got these 2 sides here. So that's side, angle, side. All right, and I can find this side here by using the law of cosines, right, where this is my in-between angle. All right, so if I write down the law of cosines, I just wrote the C law here just to illustrate what we're doing, because the reason I did that is because I saw this C here. All right, but since we're calling this X in here, let's just say, we'll go ahead and call that C just to make this easy. All right, so I'm solving for C here. All right, so we can say either this is A or this is A. It doesn't really matter. All right, so let's just do it that way. All right, so I've got everything that I need here on the right-hand side. The only thing missing is going to be that C. So I'm going to substitute into my equation. All right, I substituted everything in that I know for my diagram, and I get C squared is 222.7154, which I would then take the square root of both sides here to get C. And I type that in, and I get 14.924. Okay, so this is my shorter diagonal. All right, so now I'm going to find my other diagonal, my longer diagonal. So let me just draw that in. All right, so I draw my long diagonal in here, and a triangle either on this side, or I could use the identical one over here, it doesn't matter, would look like this. All right, it's the same setup. I have side, angle, side, except this time I've got my obtuse angle. All right, so I basically have the same setup here. Let's just scoot it over. Got the same setup. So I can just do the same calculation. The only difference would be that my angle is now 130 degrees. All right, and so I'm trying to find this now. This is my C here. All right, so I drew in my long diagonal. All right, so now we're interested in this side here. Let's see, we'll call it D, but the calculation is exactly the same. So the only thing different is my angle. So I can just go ahead and do the same calculation. All right, so I did it. Here's my equation. Here's my substitutions. So I type everything in here on the right hand side and I get d squared. And I type it all in and I get this number here. And then I just take the square root of both sides here to get my distance d. And I got that number here, 19.149. So at least it is bigger, so we were pretty sure this longer diagonal had to be a bigger number, so that works. And here's my shorter diagonal. All right, so those are our answers that we were looking for. So this triangle set up here for example 5, where we're asked to find side L, is the same triangle setup we had for one of our Law of Cosines problems, except we're going to be given some different information. Okay, so here's the parameters that I'm going to give you for this problem here. First, this is a vertical line, and this is a horizontal line. All right, so that's one thing we're being told. The other piece of information are some numbers. This angle here is 15 degrees. And this length here is 39. So this is given information. All right, then the last piece of given information is that the vertical side has a length of 170. All right, so let's just say we're working in feet. Okay? All right, so the next thing that we want to do is put on a lettering system so that we can use our laws effectively. So I'm going to say, let's call this A, B, C. And I'm just imposing a lettering system on here, which would mean this would be B across from B, C across from C, and A across from A. All right, so that way I've got, I can liken these to my laws that I'm used to working with. All right, so now the way that we normally have to deal with this kind of a problem is we need to draw some auxiliary lines. So the first one I'm going to do is I'm going to raise up my horizontal to hit that dot, my A dot right there. So that's parallel to the horizontal line. So this will also have a 15-degree angle right here. All right, and then I'm going to intersect my vertical and my horizontal lines by drawing this auxiliary line, and which means they're perpendicular. All right, so I have a right triangle right here. All right, and if this is 15 degrees and this is 90, then I can say that 180 minus 90 minus 15, which is 75 degrees, would be this angle here. All right, so that one's 75 degrees, which allows me to calculate this angle, because 75 plus this angle is going to give me my straight line angle. They're supplementary angles, 180 degrees. So my calculation for that angle is 180 minus 75 is equal to 105 degrees. All right, so over here to label it, this is 105 degrees here. All right, so now let's look at the picture and see what we can do. All right, so I've got a side on the purple triangle here, an angle in the purple triangle, and a side in the purple triangle. So that's side, angle, side. All right, so I've got a side, angle, side problem here. So that's a law of cosines problem. All right, so what I'm going to solve for here is the side that's opposite the included angle for the SAS problem. So that's always where we start with an SAS problem. So I'm going to solve for the side opposite the known angle. So that's going to be B. So I'm going to write down my B law. So here's my B law. Now I'm going to substitute in side C, which is 39, side A, which is 170, and angle B, which is 105. So I substituted all my numbers into my B law, and I type it in, and I'm going to get 33. This is what I'm getting, 852,94054. So I'm keeping all those digits. So if I take the square root of both sides, that should give me side B, 183.9917. All right, so that's my side L. So let's just go ahead and round it to the hundredth of a foot. So I'll say L is equal to 183.99 feet. So you would have to follow the rounding law, the rounding guidelines given to you in the problem you're solving. So let's highlight. So I had an SAS problem solved by using the law of cosines, and I was able to find my L right there. Okay, so we're going to use this picture again, the distance across a lake, a distance across a pond, body of water, swamp, whatever the story problem is. So these are also very common law of sines and law of cosines problems. So we have an oblique triangle here. So the information I'm going to give you, the numbers that we're going to put on our problem are this side length is 1.9 miles. This side length is 3.5 miles. And we're interested in finding the distance across the pond. All right, and we're going to be given one angle. So in this problem, I'm given this angle right here, 43 degrees. All right, so I can see already that this is an SAS problem. I've got side, angle, side. So I can use law of cosines to solve for the opposite side here. So let's just put some letters on here for my laws. So using my opposite across A from A, B from B, C from C, I put some letters on my problem here. This is somewhat arbitrary which letters you use. As long as you get the across, the side across from the angle done correctly, you should be fine. So I did that so I could use one of my laws the way we have them written. So right here, I'm trying to find little a, so I'm going to use my A law where I know angle A, so I'm going to write down the A law. All right, so there's my A law. Now I'm going to substitute in B, C, and the angle A. So I substitute all of my known quantities. Now I'm going to type that into my calculator, and I get that number for A squared. Now I want to take the square root of both sides to get A. And I get 2.4765. So the distance across the lake, all right, we're talking about miles here. We'll say the distance in miles, let's round to the hundredths place, would be 2.48 miles. All right, and you'd have to be careful that you round it according to what you are asked to do in the problem. All right, that concludes our examples. So I just want to set up some guidelines for you when you're asked to do such a thing on a quiz or in some instances on a test when you have to show your work. You would want to make sure you had a fully labeled diagram with all of your endpoints and sides labeled. Then you would want to lay out the law that you're using, write it out. Then you would want to substitute numbers into the law and simplify down to your final number. and then make sure you rounded to the correct digit and included your units. Okay, so this is the approach we would follow on any kind of a word problem. All right, so we should be ready now to attempt the homework set for section 4.2 on the law of cosines.